All right. So welcome, everyone. This is the annual Dinosaurs, the update. Let people settle on in here. Just to let you know, this year, in order to fit the virtual schedule, I'm down to the standard 50 minutes of the talks or the presentations that we're doing for this year. So this is shorter than my normal Dino panel, which normally goes for an hour and a half. So welcome everyone, and I will get my PowerPoint up and running. And my introductions are part of the presentation. So there we go. All right, so Dinosaur Update 2021. And I am Dr. Tom Holtz of the University of Maryland. A little more introduction about myself momentarily, but just pointing out, if you want to live tweet or even afterwards tweet about it, if you want to tag me in it, that's great. And also use the hashtag Balticon Dinos. It's a long-standing hashtag for this presentation. Okay, also, if you have any questions, please use the Q&A function rather than chat. You can certainly put stuff in chat for, general discussion or comments or reactions. That's fine. But we'll try to use the Q&A for the questions. Given the limitations on time, I may not have as much time to answer the questions as I'd like during the main panel, but I definitely intend to head to Discord, to the Homeland-Science room afterwards. Also, as last year, I've put together a list of the artists' websites for the artists that I'm that I'm using for this presentation, as well as links to the references in the talk. And while I'm at this, let me just post, see if I can get it all here. There we go. The various links I've mentioned so far. So my Twitter handle is there, my university webpage. I've got a YouTube playlist of public lectures, including last year's Balticon talk. And then a link of some online paleontology content that's not necessarily from me. This includes online lecture series, YouTube channels, podcasts, etc. And then at the bottom, the references for this particular talk. All right, so who am I? I'm Dr. Tom Holtz. I am a paleontologist at the University of Maryland in College Park in the Department of Geology. I'm a dinosaur paleontologist, and despite what most people think when they hear that, that is not redundant. The vast majority of people who are paleontologists do not study dinosaurs. They study the rest of the huge panoply of fossil life. But I actually specialize on dinosaurs, and specifically carnivorous dinosaurs, and even more specifically amongst that, on the tyrannosauroids. These are T-Rex and its kin. And you can see behind me a specimen of Tyrannosaurus at the Museum of the Rockies. All right, so before I get to the main part of this presentation, which are discoveries that have been published since the last Balticon meeting, I do want to review some basic concepts here so that everyone's on the same page. And I tend to use the same basic information every year because it's the important stuff. So for those of you who may be watching this on YouTube and have seen previous ones, you can fast forward. But for those of you who are live, hey, you're stuck with this. So first of all, not everything in the fossil record is dinosaurs. In fact, not everything that's cool and impressive with a skeleton is a dinosaur. So none of the creatures on this page are dinosaurs. Giant ground sloths, not dinosaurs. Fin-backed proto-mammals, not dinosaurs. Mosasaurs, not dinosaurs. Mosasaurs are honest-to-goodness lizards, just as snakes are. Yeah, snakes are a type of lizard. Pterosaurs, like pterodactyls, not dinosaurs. Close cousins of the dinosaurs, but not dinosaurs. And ichthyosaurs and plesiosaurs and the other marine reptiles, not dinosaurs. So what is a dinosaur if all those other things aren't? Well, the definition of dinosaurs that we use in modern classification is that Dinosauria is a group comprised of the most recent common ancestor of Iguanodon, Diplodocus, and Megalosaurus, and all of its descendants. So anything that fits in the family tree in this green phase is a dinosaur, and anything that branched off before that common ancestor branched off here is not. So Pterodactylus is not a dinosaur, but the reason that it's not a dinosaur isn't that it flew, because as we'll see, many dinosaurs did fly or do fly. Now, these types of definitions are what we actually now use in biology for all types of organisms. There's been a revolution in the last several decades in terms of what we call systematic biology, that is figuring out and naming the relationships of groups of organisms, in which our groups are based on patterns of recency of common ancestry. And yes, we can then use interesting features that we see, that we recognize as a way of diagnosing the group, but the definition is based on patterns of common ancestry. And even within this limited definition of Dinosauria, though, there is a tremendous variety of sizes, of ecologies, of morphologies, that is form. Dinosaur, and I'll come back to some of the major groups momentarily. Dinosaurs through time. The first dinosaurs show up at about the transition between the middle and late Triassic epochs of the Triassic period. That's about 235 million years ago. These would be forms like Herrerasaurus and Eoraptor and so forth. Our classic late Jurassic dinosaurs like Stegosaurus and Allosaurus and Brontosaurus and Brachiosaurus are about 150 million years ago. Tyrannosaurus rex, Triceratops, Pachycephalosaurus are among the last giant dinosaurs, and they died out 66 million years ago with the great asteroid impact. And of course, we are here at 0 million years ago, although we are not here at the Renaissance, although hopefully next year. And as I am required by law to say at this point, because all dinosaur paleontologists do, more time separates Stegosaurus and Tyrannosaurus than separates Tyrannosaurus and us by about 15 million years. And if you go back from Tyrannosaurus to Stegosaurus, you've only gone back half the age of dinosaurs. Oh yeah, the meteor impact was supposed to be there. It got deleted somehow. Okay. So here is a map of the distribution of Mesozoic dinosaur fossils. So this is restricting it to the dinosaurs of the Mesozoic. And we see that they're found on every continent. If you have a landmass where you've got rocks from the terrestrial realm, so streams and rivers and deserts and swamps and deltas and so forth, or from near shore environments, so not too far from the coastline, then you probably have some dinosaur fossils there. There are no doubt plenty more dinosaur fossils under the ice of Greenland and under the ice of Antarctica, which future paleontologists will have access to while coping with the catastrophic effects of the huge deglaciation of these land masses. So we're finding out about all kinds of new dinosaurs all the time. In 2020, there were 44 new species named. Here they are. Don't worry, there's not a quiz. And this year, there have been 11. Okay, seriously, it's been a challenging time for all of us. It's hard to do the work. So, hey, and this is the chart I've been keeping over the years of the number of new dinosaurs named at any given year. Now, to be fair, in some cases, these are new genus names for previously named species. That is, something that was once considered a species within a different genus has moved into a new genus, that is the next higher category. Additionally, some of the names here may eventually be found to actually to represent some previously named forms, but I don't go to the effort of taking away the names. This is showing how often we come up with new ones. All right, and so the first set of papers I want to talk about are new fossils of new species that were named since last Balticon. Oh, just to answer the question, yes, the map does include Mesozoic birds. Oh my goodness! I actually, in my efforts to take out the slides to sort of give more time for question and answers, I cut out an important set of slides. So let me deal with this. Let me back up here then. So our definition of Dinosauria as all descendants of the most recent common ancestor of Megalosaurus, who would be over about here, and Diplodocus, and Iguanodon. So we go down there, this node down here, that's Dinosauria. Well, living birds, as well as all the extinct birds, are part of Dinosauria as well, because they are the descendants of that common ancestor. So yes, birds are part of Dinosauria. Dinosauria is not extinct. And when I talk about Mesozoic dinosaurs, I'm definitely talking about Mesozoic birds as well. And they are included on this map, and they are included in these lists. Okay, so back to where I was. One of the interesting discoveries that was reported last year, actually not too long after the last Balticon, was the first discovered and presumably last surviving hadrosaurid, that is duckbill dinosaur from Africa. Now, duckbills are extremely common dinosaurs from what's called the late Cretaceous epoch. That's basically 85 million years ago to 66 million years ago in North America, in Asia. They're fairly common in Europe, but they had never been discovered from Africa yet. But at a site from the very end of the age of dinosaurs, from northern Africa, comes Ajnabia. It's known not from only this bit, it's just one of the jawbones, but it is an extremely characteristic and distinctive jawbone for a duckbill dinosaur. In fact, it has enough traits in it to help place it on the family tree. You can see the size of the individual involved compared to the other dinosaurs known from this formation so far, which includes a predator, Chenanisaurus, and an as yet unnamed Titanosaur, and a human and dromedary for scale. This said, we don't know that Ajnabia is an adult, and it could get much larger when fully grown. So here's the family tree of these duckbill dinosaurs, these hadrosaurs, and each species and the groups to which they belong is color-coded for the region in which they were found. And Ajnabia, the only African form, the only dark blue form on here was a phylogenetically nested. So think about, like, say, nesting dolls or Venn diagrams within the European group or clade of hadrosaurs. So these are the European forms, the ones in yellow, Ajnabia over here from Northern Africa. And so what it looks like, barring additional information from earlier African forms, looks like it's consistent with this Ajnabia being an immigrant from Europe, presumably island hopping, that is being rafted from island to island over the very small version of the Mediterranean that existed back then to colonize Northern Africa. Speaking of duckbill dinosaurs, earlier this year, we saw the publication of Sladalophus gallorum, which is this beautiful new dinosaur. The colors here are speculative, but much of the skeleton is known. In fact, I have to say, this paper is an excellent example of what we call an osteology, a detailed study of all the bones known from this species. It's an excellent paper. Sladalophus, the tlatl at the beginning of the name is a glyph in Nahuatl, in the language of the Maya, and it looks like this crest. This crest looks like that glyph. So that's where they gave it its name. It's appropriate for a Mexican dinosaur. And here is a reduced part of their family tree where we see it on the tree. close to the tube-crested dinosaurs of North America. But there are also tube-crested dinosaurs known from Europe and, well, from Eurasia. And so it sort of fits in among these creatures. And these different, the colors here represent the different bones that make up the crest. So an interesting new, wonderful tube-crested dinosaur. Another dinosaur, oh, that's right, it's the Aztecs, not the Maya. Thanks for getting that in. That way I'll have it spoken out loud. So I have my correction for the YouTube version. All right, another new dinosaur to come out in the last year is Bagawalio from Argentina. And Bagawalio is the oldest and among the most primitive of a group called the Eusauropoda. Eusauropoda means the true dinosaur, the true sauropods. The sauropods are the long-necked, small-headed forms, that is, brontosaurs. And although they're common in the late Jurassic, or the middle Jurassic, the late Jurassic onward, this is an early Jurassic eusauropod. It is extremely well dated because the fossils in which it were found are bracketed below and above by igneous rocks. And an advantage of igneous rocks is that you have the potential to radiometrically date them, to look at the radioactive minerals preserved in the crystals in there and estimate the age at which those rocks formed. Now, our ability to resolve time in terms of radiometric dating has gotten extremely good in recent years. Actually, one of my Balticon talks last year, which is available on YouTube, was about different methods of dating. And so we've got the bones of Bagawalio bracketed here between 1.79 and 1.78.7 million years ago. So it gives us a good sense of when it lived. Here are some previously known eusauropods from the same rock unit, but that are younger. And then below this level, we find other types of long-necked plant eaters. And what's intriguing, and what was one of the things featured in the paper in which this was described, is that Bagawalio appears after an episode of extreme volcanism, during which, let me back up over here, the flora of the region and indeed of much of the world changed. And we get these new types of pine relatives becoming the more common sorts of trees. These larger trees may have driven these larger bodied, long-necked forms as their primary feeders. And so here we have Bagawalio within the background, the volcanoes going off represent to mark this volcanic episode before them. And I should mention, since I see the name listed over here, I've tried to make certain that I indicate the artists who have done all these works, and on the reference list that I put in chat, and which I'm going to put in again, you can find the websites for all these individual paleo artists who have a lot of great stuff available. In some cases, maybe even things you can purchase, but certainly you can see the work they've been doing. All right, let me just double check in here in the Q&A if there's any questions. I see this got answered in chat as well, but let me say it out loud. When I mentioned, I had Legerpetids on one of the slides before. Legerpetids refers to Western North America. Western North America and Eastern North America were separated from each other during the Cretaceous, or the later part of the Cretaceous, by a shallow sea. I'll talk about colors later on if I have a chance. Let's see, I answered that one live. Did the trees get longer due to the pressure put on the herbivorous sauropodomorphs? So there was an arms race between trees as they became bigger and bigger. That is a possibility. It also could be that they grew larger in response to other environmental factors. In this case, it looks like there was a drawing event that favored these trees related to the modern monkey puzzle tree, or Araucarians, which are actually still quite common in the, well, relatively common in the southern hemisphere. It used to be globally distributed forms. And taller trees would certainly favor very large animals to feed on them. And of course, larger animals to feed on them is going to favor taller trees. All right, so going from giants to some small animals, one of the creatures named last year was Falcotta a Cretaceous pseudo toucan. It is not a true toucan. It is, in fact, not a member of the modern bird group, but is a more primitive member of the bird lineage. But similar to the modern toucan, has a rather deep bill. Although this deep bill in the front of the snout, there actually is, there are a couple teeth. Most birds of the Mesozoic still had teeth. The loss of teeth was a relatively late event in bird history. And also just a little bit of anatomy here. The modern bird bill is almost only made up of the premaxilla, which is this bone here on this particular dinosaur. So this bone over here, the maxilla, which makes up the snout of most dinosaurs, indeed most animals, is highly reduced in modern birds. And that's how you could tell, among many other things, that this is not a modern bird. A modern toucan, its huge bill is mostly the premaxilla. And so this plot from that paper shows you the structure of the bills of a number of Mesozoic and one modern dinosaur, that is bird. So here's Archaeopteryx, a very early bird. Here's Gallus, that's a chicken. And here's Falcotta in context here. Or is it in context? Because although this hasn't been published as a paper per se, it is in a blog by a professional paleontologist, Andrea Cao, a colleague and co-author of mine, who also, like me, works on carnivorous dinosaurs. And he's put forward the hypothesis that this skull may actually belong to a previously named dinosaur. There's a small, long-armed dinosaur from the very same rocks called Rahonavis, a small raptor or raptor relative, which puts it very close to the origin of birds. And this skull, the upper part of the skull of Rahonavis was never recovered. It's about the right size. So we'll have to see if future skeletons wind up attaching Falcotta to Rahonavis. Okay, let's pop over and double check over here. That's done. That's done. Was the shallow sea over the modern prairie, Kansas, etc.? Yes, that's correct. In fact, there's a wonderful book, a second edition of which now exists, from Indiana University Press by Michael Everhart, called The Oceans of Kansas. Let's see. Oh, hang on. Cancel. Answer live. Done. Don't you love people narrating stuff on the computer? Okay. Answer live. There we go. Oh, wait, hang on. Back up. So one of my favorite little dinosaurs, or group of little dinosaurs, are the Alvarosaurs. Alvarosaurs are not generally known that much to the public. Shibuya and Mononicus are the two best known forms, and because most of you have probably never heard of those names, that shows you how relatively obscure they are. They're small-bodied dinosaurs with beaky little snouts with tiny little teeth. They are most famous for extremely short but extremely powerful front limbs with one gigantic thumb claw and sometimes two very small other claws, but sometimes no claws at all. And these are dinosaurs that are literally all thumbs. Well, back in 1995, I mentioned as a footnote in a paper that came out then that I thought I had discovered a specimen that might belong to this group that had been discovered in the 1800s by Yale paleontologist O.C. Marsh. And in the year that followed, some of my colleagues working at UCal Berkeley found some other remains of an Alvarosaur from these same rocks, the very youngest non-bird dinosaur rocks of North America. It's called the Hell Creek Formation of Laramidia. Well, not too much else was discovered in the intervening years until the last several years when more bits and pieces of a Hell Creek Formation Alvarosaur was found. And so finally, a team led by Denver Fowler gave this creature its name, Triarchonchus prairiensis, and the genus name refers to Captain Hook because of its thumb claw. And Alvarosaurs also have been the subject, or at least partially the subject, of a couple other recent discoveries. Alvarosaurs are very peculiar, but at least we've got some really good skulls from some of them. And in recent years, the ability to CT scan using the same technology we use in medicine to do CT studies of the insides of bones and so forth of human patients has given us a lot of information that we couldn't get otherwise, because you couldn't get into those parts of the skull without breaking them apart. And preserved within the skulls are such features as the organs of balance and at least the hard tissues, or rather these pieces of tissues that are associated with. And some recent papers have come out that helped us resolve some issues having to do with the senses of various types of dinosaurs and their relatives. In fact, two big papers that came out back to back in the same issue of Science looked at some of this. In this first paper by Hansen et al., they looked at what we call the semicircular canals. These are the organs of balance in the head, and it helped show which forms were most sensitive to different aspects of pitch and yaw and so forth. And that helped us sort out which animals were really best at high maneuverable flight. And it shows us that primitive modern birds, what we could actually confirm anyway from the living animals, are less sensitive towards high maneuverable flight, and that high maneuverable flight is a feature that evolved within the group of modern birds. It was not present in Mesozoic birds. But as part of this study as well, they looked at the cochlea region of the inner ear to look at the sensitivity towards high frequency sound. And they found that in crocodiles and all the extinct members of Archosauria and that they looked at, Archosauria is the group that contains crocodiles, birds, and all descendants of their most recent common ancestor. And this includes pterosaurs and dinosaurs. All of them actually had a very high, good sensitivity to high frequency sound. Now, in crocodilians and birds, there's parental care of the young. And the young, of course, make high frequency sounds. And so they, the authors here suggested that, as we already inferred based on their evolutionary position, perhaps all archosaurs were creatures that took care of their young, and that the young communicated with the adults with these high-pitched peepings. Well, in the paper immediately following that, they looked at both hearing and vision. And part of that study looked at the relative proportions of what we call the sclerotic ring. This is a ring of bones that's in front of the eyeball relative to total eye size as a metric to test for creatures which are more diurnal, that is active during the daytime, versus nocturnal. This is building on previous work. And they found that the Alvarosaurs tended to score quite highly in terms of their nocturnality. They also found, similar to the previous study, looking at the sensitivity towards high frequency sound, that the specialized, the more advanced members of Alvarosaurs had the same level of sensitivity of hearing as a barn owl. So this was something that no one really expected to find, that level of sensitivity. And so this has led to a new look at Alvarosaurs. We already suspected that they were insectivores and that they used those short but powerful limbs to break into nests of insects of various sorts. But now it turns out they seem to have been nocturnal and very sensitive to sound. And so that says maybe we should call them Owlvarosaurs. So, and here you see some Alvarosaurs done intentionally to look like a barn owl. We have no reason to suspect they had barn owl faces, listening in on a beetle down here that they're going to then dig up and munch on. Okay. So yeah, okay. Oh, lol, Dad. Okay, very, very good. Let me just double check in terms of the questions here. Okay. All right. Now, another paper that came out, and actually not too long after the last Balticon, was a study that looked at dinosaur eggs and has called into questions basically everything that we used to think about dinosaur eggs. That is, were there any dinosaurs with soft-shelled eggs? Now, what do I mean by that? Most amniotes, that is, most animals that lay their eggs on land, have what we call leathery or parchment shells, soft-shelled eggs. So we find them in egg-laying mammals, like the echidna and the platypus. We find them in squamates. Those are lizards and snakes. We find them in tuataras, which are cousins of lizards and snakes. And we find them in the majority of types of turtles. So leathery shells are widespread. However, the two living groups of archosaurs, crocodilians and birds, have crispy eggs, eggs that are calcified, that when we think of eggshell, that's what we're thinking of mostly. So the simple inference had been, well, if crocodilians have crispy eggs and birds have crispy eggs, then the simplest solution evolutionarily is that the common ancestor of these two had a crispy egg, and all descendants of that ancestor, this would include the early proto-crocs and proto-birds like dinosaurs and pterosaurs, would have had crispy eggs. And everyone was comfortable with that. Well, there in fact was fossil evidence to support crispy eggs in at least some types of dinosaurs, and from all three major branches: Titanosaur sauropods and duckbill ornithischian dinosaurs, those are the bird-hip dinosaurs, and a wide variety of members of the carnivorous dinosaur group called Tetanurae. So we thought, simple solution, all dinosaurs had crispy eggs. Now, in fact, and here's some Oviraptorosaur eggs, or a type of theropod with crispy eggs. There was one fly in the ointment we already knew, and that is pterosaurs, which are also a type of archosaur, did have the leathery egg that had already been found. So the simplest solution was that pterosaurs over here had undergone an evolutionary reversal, that the common ancestor of all archosaurs had crispy eggs, and pterosaurs just reverted to a leathery egg. Then along comes 2020, and a paper with a large number of my colleagues working on specimens from around the world that demonstrated that several types of plant-eating dinosaurs, these include Protoceratops, a famous cousin of Triceratops, as well as a variety of the early members of the long-necked plant eaters, the sauropodomorphs, had soft-shelled eggs. And we happen to have them preserved because of fossil mineralization, not the actual mineralization of the eggs to begin with. And so when you start to plot these out, depending upon whether you use a likelihood metric, well, if you use a likelihood metric, then unquestionably the first dinosaurs had soft-shelled eggs and crispiness evolved independently. Or even if you use what you call a parsimony method, what's the simplest solution, all other things considered, either we have a crispy egg ancestrally for archosaurs with a variety of, with four reversals, at least four reversals, or a soft-shelled egg, and at four cases independently of crispiness evolving. Those are equally parsimonious solution. So freaking 2020, man, it's totally inconclusive at the moment. So that's just happened. That's nature for you. We'll need some more. All right. Now, Spinosaurus. Every year, something new with Spinosaurus. And this year was something new from myself and my colleague, Dave Hone. We had a paper that came out earlier this year on the ecology of Spinosaurus. Now, in previous years, and in fact at Balticon last year, I discussed how the newly discovered tail of Spinosaurus suggested to some people that it was, in fact, a swimmer. The tail is quite tall, with extensions going above and below. And this was interpreted as sort of a sculling tail. The people who described it as such, though, also went on to talk about how they interpreted Spinosaurus as a swimming predator, that is, was chasing its prey in the water quickly, that is, a pursuit predator. Well, Dave and I had some questions about that. And so we went through and examined many aspects of the anatomy of this dinosaur. And we pointed out, for instance, that although their nostrils, and this little opening here, that's the nostril, was placed far back on the snout, it wasn't placed far up on the snout. So it could use its snout to dip into the water and still breathe. But if it was trying to swim and breathe at the same time, either most of the head had to be out of the water, or it had to do something sort of like this. It's not like the nostrils of, say, a crocodilian, which are placed as high as the eyes. It's more like the eye on the, the nostril on a stork, which dip their heads into the water. Additionally, because it's such a large animal with this tall sail, in order to avoid issues of what are called, wave drag effects, it had to be very, very deep in the water, and yet it's living in river channels. So instead, we interpret it as a generalized shoreline predator. It certainly swam. It was probably a better swimmer than most carnivorous dinosaurs. But we interpret it as feeding as much, if not more often, while it was standing around than swimming after the prey. That although, you get these wonderful animated reconstructions of them swimming after large fish in the water, we think that that was not its normal mode of feeding. All right. Jurassic Cannibalism. So a paper that came out last year by Stephanie Drumheller and colleagues looked at a particular site in what's called the Morrison Formation. This is the late Jurassic of Western North America, where it seems that unlike most Morrison sites, there was an extremely high frequency of bite marks by carnivorous dinosaurs on the bones. And many of the bones in question were actually other carnivorous dinosaurs. So this is a photograph of that site. It's called the Mygat Moor Quarry. I took this picture back in, I think, 2006. It's near the town of Fruita, Colorado. And in the Drumheller et al. Paper, they found a much higher frequency of bite marks than at typical Morrison Formation sites. And the patterns of scratches on the bone were consistent in terms of the size and shapes of the scratch marks with the two most common large carnivorous dinosaurs from that formation, Allosaurus and Ceratosaurus. So no huge surprise. In fact, the bones of Allosaurus and Ceratosaurus were represented in that formation. And indeed, they found there was a fair number of Allosaurus bite marks on Allosaurus bones and Ceratosaurus bite marks on Ceratosaurus bones, and vice versa as well. That's worth noting. And the bones that were eaten of theropod bones tend to be what we call lower economy bones, things like feet and so forth, where there's not a lot of meat on them. And this suggested that this particular quarry represented a stressed out environment where these animals were eating as much as possible over the food. Oh, couldn't they be fighting over territory? Some of these bite marks are like on the insides of ribs or on the lower surface of vertebrae that would be deep underneath the guts or above the guts. So yeah, these animals were definitely eating other dead animals. No doubt they were biting each other as well, but these particular bite marks were not antagonistic bites. Were there any bites from Torvosaurus? A couple may have been from Torvosaurus, and indeed some of the bite scratches were from a very large theropod, which was either a very big Allosaurus or a Saurophaganax, which may just be a very big Allosaurus, or from Torvosaurus, which is another giant predator. All right, I don't have too much time left, but I don't have too many more papers to talk about, so that's good. How far did hadrosaurs, that is duckbills, migrate? And I chose this paper to talk about because it shows you the diversity of types of approaches we can use to understand dinosaur biology. Hadrosaurs or duckbill dinosaurs have been suggested to have been great migrators because many of the same species are found across large distances. But how do you tease out if that one species is widespread, but the individuals stay in place, versus individuals migrating back and forth over long distances? Well, this team looked at an individual, sadly just one, but this work could potentially be expanded, one individual of a duckbill dinosaur from a particular quarry, and they looked at the teeth. Now, the nice thing about hadrosaurs is they retained many teeth in their jaw, so you could look up through a series of teeth and see, a development over time. And they sampled the strontium in those teeth that's preserved there. They also compared that to the teeth of animals no one thinks were migrating, things like garfish, turtles, well, not teeth of turtles, bones of turtles, scales of garfish, teeth of crocodilians, and of small carnivorous dinosaurs. Now, strontium values tend to be limited, tend to differ from river valley to river valley. And they did find that any given carnivorous dinosaur or crocodile or skate or gar had a very limited range, and the hadrosaur had a wider range. But when we compare, and I wish they kept the colors consistent, if we compare the hadrosaur individual, which is in salmon over here, to the different river valley systems they had to study, let's back up over here, color coded here, they found it really matched just one or possibly a couple of those river valley systems. And so it looks like that one individual hadrosaur was not traveling very long distances. So perhaps, although the species were widespread, they weren't engaged in large-scale migrations. Of course, this is just one study. Additional work is needed. And the last paper I wanted to mention here is something that's not about dinosaurs, but about their cousins, but I still think it's pretty cool. And that is, we now have evidence of what the proto-pterosaurs look like. So pterosaurs, the flying reptiles. For long, we've known about pterosaurs even longer than we've known about Dinosauria, but they were so transformed biologically, it was hard to see what their closest relatives are. But now we've got good evidence that their relatives were a group that we already knew from the Triassic period called the Legerpetids. And this is a reconstructed Legerpetid. So pterosaurs, the wing reptiles, things like Rhamphorhynchus here, or Pteranodon or Pterodactylus, long known, but they're evolutionarily so transformed, it was hard to see what they came from. Now, initially, these creatures, the Legerpetids, were thought to be proto-dinosaurs, much like their close relatives, the Lagasuchids, like Marasuchus here. But, oh, by the way, collectively, these two groups have been nicknamed the bunny crocs. That's what Lagasuchus literally means, is rabbit croc. But now that we've got many more Legerpetid skeletons than before, and also new techniques to study the skulls, the brain cases, and so forth, a number of attributes were found inside and out that linked Legerpetidae, which is the Legerpetids, and pterosaurs that weren't known before. And so we went from this view, where pterosaurs were one branch and Legerpetids were closer to dinosaurs on the family tree, to finding them as proto-pterosaurs. And this gives us more information about how pterosaur flight may have originated. Legerpetids were thought to have been fast-running animals, but there were other animals that have very long legs, the way Legerpetids did. And think about the Shifaka lemur of Madagascar, or various types of the bush babies on other continents in the old world, or many types of long-legged lizards that we call vertical clingers and leapers. And so it may be that Legerpetids, or proto-Legerpetids at least, represented a group of vertical clingers and leapers, which were the ancestors of the first gliding and then eventually flying pterosaurs. All right, so I'm wrapping things up here. I do want to say that the National Museum of Natural History is still not yet open to the public, but on June 18th, it will be open again. So if you go to si.edu, you can start booking tickets soon for timed entry. They radically updated their paleontology halls in the June of 2019. You can visit it virtually at the site here. Additionally, I had put together a list of online videos and lecture series and podcasts related to paleontology for those people who want to see more paleo content online. And I'll post these links again down here. I also want to point out that tomorrow at 1 p.m., I'm giving a presentation on Charles Darwin, fossil hunter. We tend to think of Darwin as an important biologist, and of course he was very famous as a biologist, but he actually contributed a lot to geology and paleontology. And I might be able to take a couple questions. I'll have a little time to deal with questions here. But after the panel here, I'm going to go over to Discord. I'll be in the Homeland Science section. These are the links that I just posted in chat. And I want to thank you for your kind attention. And let me stop sharing here, and let me see in the Q&A. I see there's a lot of questions here. Let's see what I can get to. Here's Q&A. All right. Let's see. Since they aren't dinosaurs, it's Lance. Hi, Lance. I'd love to know if there are any significant finds or studies in the realm of marine reptiles this past year. By the way, Lance, congratulations on graduating. The big discoveries in marine reptiles in the last couple of years is increased evidence that that plesiosaurs, ichthyosaurs, at least parapelvian ichthyosaurs, which are the ones that look like fish, and mosasaurs may have been honest to goodness warm-blooded, and I think that's pretty cool. Would this make pterosaurs dinosauromorphs, or does it make Legerpetids pterosauromorphs? Legerpetids are pterosauromorphs because Pterosauromorpha is pterosaurs and everything closer to them than to dinosaurs. Dinosauromorpha is defined as dinosaurs and everything closer to them than to pterosaurs. Let's see. Scrolling back up here. The sauropods laying eggs remains a good question. They don't look like squatters. This may be one of the cases they actually did use the tails for support. And it definitely looks like they used both the hind and perhaps the front feet as well to dig out pits for laying their eggs. Let's see. So the shells probably didn't drop the 6 to 10 feet to the ground. They probably did something to get them closer to the ground. And indeed, we absolutely know that the largest sauropods actually had crispy eggs. Let's see, what else do we have here? Besides T-Rex, are there other really feared dinosaurs? Well, there's a huge diversity of giant carnivorous dinosaurs. Now, I work on tyrannosaurs, so I happen to think that they were the most awesome. But there are plenty of other carnivorous dinosaurs that you wouldn't want to meet in a dark alley or a brightly lit alley or a parking lot or anything like that if you can't get away. If you can't get away, it would be cool. Let's see. See if there's anything else to mention here. How do they know if Sladalophus is separate from Parasaurolophus and Coronosaurus? In the paper in which it was described, they detail the attributes of the anatomy where those three overlap and indicate how it's distinctive from all of them. Oh, and as Kelly W. points out, large non-carnivorous dinosaurs would be equally feared. Absolutely. I mean, you don't want to mess with a bull. You don't want to mess with a rhino. You don't want to mess with an angry horse. So yeah, you wouldn't want to mess with a horned dinosaur or a sauropod or a hadrosaur. All right. And yes, the lamp, it's not Tiffany lamp, but it's Tiffany light. It does pop in behind my head. It amuses my students when that happens. And let's see. Yeah, ankylosaurs would also definitely, you wouldn't want to mess with them. Well, I will say that thank you for your kind attention. Hopefully next year, this will be in person. And hopefully next year, it will be extended length. So take care and see you over in Discord for those who want to join me there. And that's Homeland.